Hello, everyone, and welcome to another ConsenSys Cypherpunk Hackathon workshop. We have Dan with us again. Doing this one is going to be on secure extensible JavaScript. So he's going to be talking about stuff in MetaMask that they're working on and have used that they didn't think was possible. So this is going to be exciting. He's going to be sharing some insider scoops here today. Just a quick Crowdcast housekeeping. This is the platform we're using today for this workshop. On the right-hand side, you have the chat, and that's going to be going through the whole workshop. So feel free to chat away in that area. If you do have specific questions you'd like Dan to answer, please add them to the Ask a Question queue at the bottom there. This twofold, it will help us to kind of see what questions to prioritize and kind of like I can ask Dan to kind of answer when it's relevant. But also, if you're interested, we can invite you up onto the stage to ask the question yourself and interact with Dan. So that's really cool. And if you if you start typing in chat and then you put a question mark before you hit return, you'll notice a little orange button pops up. It says, would you like to add this to the queue? And if there's any questions in the queue that you notice, yeah, I'd love to hear that answer too. And then upvote it. And then we can make sure that we get to that quickly. But of course, if we, don't get to your question while through the workshop, we always leave a little time at the end to answer any remaining questions. This will be available as a replay. This Crowdcast workshop, as well as all the workshops, are available at their same link that you RSVP'd and that you're viewing it now. The replay will be available. So make sure to join our ConsenSys Hackathon 2021 Slack channel. That's where we'll post all the slide decks, all the replay links, and also our shiny green button at the bottom there. Is basically information about this event, the Cypherpunk Hackathon event in general. All the workshops that you can still RSVP and check out, as well as watch replays, check out the slide decks, but also actually sign up for the hackathon itself, which is June 7th through 11th. We're doing team building sessions this week and next week. So if you have an idea, this is your chance to finally give it some legs. It doesn't matter if you've ever done this before. We'll help you get a team together. We'll help you vet the idea so that you can figure out the best deliverable to submit for consideration. And of course, there's some really great rewards and prizes. So use that sign-up form to express your interest. You may not have an idea and you just want to jump in and work on a team and hack out an idea. That's also great. So, and hopefully this workshop today that Dan's doing will inspire you with some ideas, maybe around MetaMask and extending it and all that good stuff. So I am Shay, by the way, and without further ado, I'll hand the mic over to Dan.
Hey, thanks a lot, Shay. I'm actually getting a little feedback. I hear myself right now. It's driving me slightly crazy.
Your audio sounds okay on this end.
Okay. You know what I'm going to do?
That might be distracting.
Yeah.
You want to switch microphones?
Sure. Let me try that. Sorry.
Yeah, no problem. And while you're switching, let's see. Oh, yeah. I think Ryan, he was just saying hi and you asked him a question. So yeah, again, anybody who is interested in queuing up a question, feel free to do that. Also, in terms of if you want to reach out to Dan after this, maybe you can't think of the question, you need to marinate on some of the topics, which happens a lot. Of course, he's available on Slack after this. You can jump in the channel or you can just DM him, the ConsenSys Hackathon 2021 channel, or DM him directly, and he'll be happy to, talk with you about your questions. So yeah.
Okay, sorry about that.
Yeah, of course, Ben. We were trying to accommodate, different parts of the world, so that's why we're doing a different time on this workshop so that you guys can tune in. I know they're available, of course, but it's always nice to be on the actual live workshop sometimes. So good to see you, Ben. Or good to hear from you on the chat. So how are you all set there, Dan, or did you want to test it real quick?
Yeah, no, it's working. I just also hear myself through my headphones, which is really weird. I almost think that I'm watching at the same time, like in another tab.
Maybe do you have two tabs open? Oh, that's what it is. When I had two Crowdcast tabs open, it was doing an echo. That's probably what's happening.
Right. That would. Oh, I found it.
Yay!
I'm so sorry.
Thank you, everyone, for your patience. We're just working out.
Thanks for bearing with.
Yeah, it's like, yeah, you got it. Sweet. Okay.
Whoops. Okay. All right. Let's go. So thanks everybody for coming. I'm Dan Finlay. I'm the group manager over at MetaMask. I started making a wallet so I could decentralize power, but also wallet UX isn't where I need it to be to do that. So I'm doing that. I think the wallet's got a lot of room to grow, and we'll talk a little bit about that. So this is going to be a slightly weird talk. I'm going to talk a little bit about background on MetaMask, but then I'm going to dive into this set of tools that we've been playing with a little bit at MetaMask, and I kind of want to just show you some of the tools that have been making new things possible for us, hopefully in a way that you can make use of them in your own projects as well. So what this is not a status update or an explainer on snaps, nor is this even how to use Lava Mode, although I'll give a really brief description of each of those. Instead, it's going to be a tour of technologies that are enabling us to do things we thought were impossible a couple years ago. Okay, so it's a really big topic, and we got an hour, so let's see how much I can get to you guys. So the background is, and I've done like 5 variations of this slide in the past, but MetaMask, sandwiched between the dual kind of conflicting incentives of safety and innovation, right? Here we are building wallets on the blockchain. We don't want to lose people's funds, seriously, never. But also, we've got a lot of stuff to add. And in fact, we're trying to keep up with this permissionlessly extensible platform, Ethereum, which is just so powerful to build on. But how do you keep up with the foot race with a permissionless ecosystem, right? Oh, and by the way, every time you add another feature, you probably increase your risk. A new dependency could steal stuff. You could have new malicious contributors sneaking in code you didn't notice. There are studies that show that you can pretty much always obscure some malicious code to look friendly, by the way. So every time you have a new strange contributor introducing some code that you maybe don't have an intuitive understanding of, or maybe if you didn't scroll all the way to the right, there were some extra characters over there. Lots of ways of sneaking in scary stuff, right? Not to mention mistakes. So, and this isn't just like hypothetical paranoia. Like real Bitcoin wallets written in JavaScript have been hacked just because a single dependency got a little cavalier with their maintenance assignment. And so you import a dependency. What does that bring with it? You're kind of bringing in whatever arbitrary governance that module has, and maybe it's actually kind of just a casual thing, and they never expected you to use it to secure users' funds, right? So what kind of borrowing from the popular Lava Moat pitch here. Don't worry, I'll get into fresh terrain here soon. But the popular responses to this kind of duality is, well, either don't import code, just write all of your code by hand. It sounds like the real death of innovation to me. Audit all of your code. Sure, we do that, but with dependencies and with trying to keep up with things, it still puts a pretty heavy burden. And even if you're auditing, let's say twice a year or 4 times a year, there's periods you're going to probably be shipping code that you're not auditing. You can make a culture of auditing. Oh, you can murder the person who maintained the module that got compromised. Obviously, we'll run out of modules really fast if we do that. Maybe software is all garbage, and we should just give up and try living off the land. And haven't totally discarded that one yet, but let's give computers a good shot. Yeah, I'm not endorsing murder. That's a joke for anyone. Our lawyers have advised me to clarify explicitly. Or we can just work harder to keep up with all the innovation. All right, but there was a unique take in the aftermath of that hack. Zuko Wilcox, the founder of Zcash and the electric coin company, he said, hey, people are saying, you should reuse code or vet authors more or something. But instead of talking about making code reuse safe. And he says, that's why I think Agoric's important. And we're like, making code reuse safe? What the heck is he talking about? And I look at their webpage, and it wasn't very flashy, so I kind of put it away for a while. But eventually, I got to meet them, and their team has a bunch of early web pioneers, people who worked on the first web browser, the first online exchange, the first massive multiplayer online game. And they've been working on these kinds of distributed systems problems for decades. And they've kind of converged on a security model that enables distributed security that they're very fond of. And about a decade ago, they were convinced that JavaScript might actually be the language for this kind of distributed security they were trying to build. And I was like, what, JavaScript? JavaScript, I put that in italics because most people hear JavaScript, they do not think a secure language. They think of a big security nightmare. They think about, not a number jokes and things like that. But it turns out JavaScript has a lot of properties that make it kind of convenient to express what they call object capability programming. This is a security model where the languages, it's based on object orientation, so object-oriented programming. So, JavaScript is a prototype-based language, but you can use it in an object-oriented way, and you can use it in a way where you use lexical scope as the security policy. So you would say that no object gains access to another except by explicit introduction or instantiation. So in this case, Alice, this is called a Granovetter diagram. Alice, by the arrow, has a reference to Carol, and Alice has a reference to Bob, and she is able to hand her reference of Carol to Bob in the form of this foo pointer. And these could be different objects in the same program, or these could be different computers. They could be different processes on the same machine. These could be computers across the network. But what we're able to do is we're able to represent a reference to Carol, or even just a function that Carol exports. Maybe this is the unlock Carol's front door or starter car function. You can just take that function, you can pass it to this other function named Bob, and now Bob has a reference to the foo start my car function. And by having a reference to it, you have access to it. And so what they say about object capability programming is the reference graph is the authority graph. It's a slightly different way of programming, but it's actually pretty natural in JavaScript to simply, pass something the function it requires to do its work, and no more. You can even wrap a function that you pass with a security policy like an extra attenuation. But it's a way of expressing a very, very fine-grained security policy in a potentially totally distributed environment. So let's dive into that a little more. So I'm gonna give you a big stack of tools and kind of key terms. The first one is secure ECMAScript. Secure ECMAScript is this. It's right here. It is a subset of JavaScript strict mode. So if you're familiar with JavaScript, if you just start typing in the console, you get a lot of kinds of weird things that can cause messes. But if you enable strict mode, you've now excluded all of these weird behaviors that you're probably not that familiar with using anyways. But then SES goes one further, and it excludes mutable primordials and ambient authority. And what we mean by that is every time you import a module today off NPM, it gets access to all your primordials that, like, let's say the prototype of array, or and ambient authority, it gets like access to the require statement directly. And so that means it can change what it means to access an array. It can potentially read every array that you have. It means that it can dynamically do anything that your root code can do. It could import its own modules. It could provide its own imposter modules in response to your own require statements. So yeah, obviously we're not going to have a safe language if we have those. And so we have SES, which allows us to cut those dangerous parts of the language out of our usage. And you can actually use this today. There's a SES shim. You can import SES, and you can have a global function called lockdown. And now you don't have those. So if you do this on your JavaScript projects today, some modules may stop working, but you will have eliminated a huge number of vulnerabilities, including the one that I showed on screen earlier. Well, sorry, not exactly. If you also did this to your build process, you would have to do that to also secure this. And that's the kind of thing that we're working on at MetaMask. So we have locked down our build process, our background process. We're working on, I think we've locked down our foreground, and we're working on also lava moding it. And it's a pretty simple thing to do. You'll probably get some errors. And most of those errors will be things like one of your dependencies is doing something kind of sloppy that it probably shouldn't be doing anyways. And so by adding these two lines to your code, you kind of encourage some like security best practices across your entire dependency graph. And that's kind of a nice community behavior to do. In addition to the lockdown function, SES brings with it the Compartment API. This is, I think, like stage 2 at TC39. So we're trying to get this API added to JavaScript environments. There is some pushback from some of the browser vendor developers, but there is also a shim for it. And it is also available in some JavaScript runtimes, like the Moddable, the XS engine from Moddable IoT, which is an IoT company that does. They do like embedded systems that can run JavaScript, and it includes this API. So what it lets you do is you can make a new compartment, and that gives you a safe little area that you can evaluate code in. That's pretty crazy, right? So yeah, okay, evaluate code, but what can this code do? In this example, this code can do nothing because we passed the compartment no arguments. But we can pass the compartment an object that represents keys and values that we want to be assigned to the scope of the code that gets evaluated from this compartment. So I was looking for nice little examples. And so apologies, I found a slightly bigger example, but this is working code from an experiment that I did. So let's say we wanted to make a chat bot, like a Discord bot, where every user gets access to a terminal, a JavaScript terminal, so you can kind of like execute functions in public, and you can show them to others, and they can share them too. So then you could like make a vote function and share it. So we made this, and it looks kind of like this. And so when a user sends their first message, we get that user's ID, and we give them an inbox, and then we make them each in a compartment. And these are the objects that we give their compartment access to. So E is a helper function, console, obviously. We give each user an access to their own ID, a special box for sharing things with other users, an inbox for getting messages from others, a send function for sending exclusive access of things to other users, and then just a map of others. So it's like a really, really simple thing. And then we save that author and compartment. So we've made a compartment. What I'm showing you is when you construct a compartment, you give it its endowments. And then on this next slide, I'll show the important part, which is the Compartment Evaluate. It's this line here in the middle. So here is now when this chatbot gets a message, here's the handle command function. This is the whole function to safely confine individuals' messages. So we have a special like root method, so you can ignore this. So we go and we get the author, and this is the same author that we saw on the last slide. So there's an author.id and author.compartment. And then we just say evaluate their thing. And if there's an error, we catch it. And otherwise, we give them the result. And there we go. We've implemented a REPL in a chatbot where users can't interfere with each other's state, but they can share functions. And they have like a real-time collaborative programming environment. Now, there's a caveat. These users, of course, can perform infinite loops, right? So that would be a challenge in this environment. But there's a solution to that. Also, from the Agoric stack, there's this thing they call a Swingset, another key term from the Agoric lexicon. Swingset builds on the WaterKen research from HP Labs. HP Labs had this whole series of research projects where they actually built a distributed Java programming environment called WaterKen. And they did a lot of cool research with it, and they had working applications that enabled sharing files and other stuff on it. And so what this does, so Swingset is the idea that we now take any virtual machine and make it deterministic and persistent. So what we can do from our earlier example, so we've got a handle command, and all machine state, if all machine state is derived from processing these handle command prompts, and we have no sources of non-determinism, and so we saw I didn't provide math here, you might notice. So there's no math.random. So these users don't have any access to random numbers. And so we can actually just replay these messages. And now we've made a swing set. So every time the machine boots up, it can replay all the messages. And that's the simple kind of naive approach, just like a blockchain, right? You replay all the messages on a VM and you get a deterministic state. With XS Engine, again, from Moddable, there is now a JavaScript runtime that can do snapshots. And so if you got into a JavaScript runtime that had a really, really long history, then snapshotting lets you not replay messages. You just reboot from that point in time. And that means now we could have kind of a JavaScript console that is persistent between sessions and is efficient to kind of resume. So that's kind of cool. All right. So what could we do with that? Okay, maybe it could let us do an actor model, right? But that would require that it also be able to share references between other swing sets. And that's where CAPTP comes in. Okay, CAPTP, short for the capability. Oh, right, and I'll explain the names. Swingset because it's next to a sandbox. That's the cutesy naming. Forgive me, I didn't come up with it, but it's like a lightweight sandbox is the idea. CAPTP, or Capability Transport Protocol, is the idea. Okay, so if we've got a bunch of swing sets, we have our individual JavaScript runtimes, and we want to be able to share functions with each other, but not just in the same runtime. We want to be able to share functions with each other across the process boundary. So that means synchronous functions can't work, right? Or you could have it, but it would have to be blocking on your thread. So CAPTP is actually, it's a module. There's a few versions of it. So it lets you basically pass object references, much like you would in a local environment, to things across an async boundary. And we then call them presences. They're not objects anymore. It's constructed using the proxy API. Proxy API is a really cool JavaScript API that lets you create hooks for any getter. And so you can have a presence that lets you call any function on it. Like you just make up a name. And if there wasn't a function named to that, it'll fail. But what it'll do is when you invoke a function with a name, it turns into a message over the network calling to the host of that function, asks them to run it, and then they return, either an error or a response. And so this is basically a framework for extending that object graph that allowed us to get really, really tight local security out of the JavaScript language. And this is a framework for basically continuing to pass around objects in a very similar fashion across the network boundary. So it's intended to make distributed safe programming as simple as possible. So there is a version working in JavaScript, and it works nicely between JavaScript processes. There is also a variant working in Scheme, and there is a bridge between the Scheme and JavaScript versions. This is called Sprightly Goblins. If you follow Dusty Web on Twitter, he's currently working on Sprightly Goblins. This is Christopher Lemmer-Weber. He was the creator of the ActivityPub protocol. So if you're familiar with Mastodon or any of that kind of dweb stuff, like he is no longer working on that because he is convinced that just having a queue of messages between people isn't enough. You need to be able to share capabilities as well. So imagine a chat room where you can drop function references as well as chat. He's working on a big presentation to kind of show off his vision for that right now. He's currently working with MetaMask and Agoric and more. It's a growing consortium to develop a kind of cross-language CAPTP. So we could have kind of object references that are as friendly as possible in a cross-language way. We're currently, kind of deliberating what's the friendliest thing you can do for example, strongly typed functions and things like that. But it's just kind of a ergonomics question right now. Like we know how it can work, and we're just trying to make the friendliest distributed programming environment that we can. And so the Sprightly variant also has handoffs. What's cool about Sprightly is it's building on Scheme, which is a Lisp-based language that lets you kind of really easily add additional syntax. And by adding his own syntax, Chris has been able to iterate on his version of CAPTP faster than Agoric or the JavaScript version has. And so he's been able to demonstrate like eventual framework improvements like handoffs. And what handoffs is let's say you've got Alice, Bob, and Carol. Any one of them can start a chat room and invite another. And then that second, Alice can invite Bob and Bob can invite Carol. And then Bob can go offline and then Alice can go offline, but Carol's still going to have her own kind of reference to the chat room and be able to add messages to it and kind of continue the experience all without a server. This is because the objects, they aren't just references getting passed between. So it's not like Carol has a reference to Bob's Alice. It's like after Bob handed Carol his Alice, the machines were able to hand off and basically deduplicate the references. It's anyways, I can't go too deep into that because I need to read that code to better grok just how he's pulled it off. But it's been one of the long-term dreams of the CAPTP protocol, so it's really exciting that it's happening. Okay. Another example just in that lexicon, this one's a real small one, but there's also a notion of there. So once you have a safe execution within your environment in an object graph that can be distributed, you can also solve deadlocks in a creative way. So for example, I've got this library called Kaputu that makes it really easy to construct objects that are easy to share over the network boundary. So if I make a map with its grain map, I've got a counter with a number and foo is bar. I can then pass that object over CAPTP, and the other person on the other side of the network gets an equivalent presence. This isn't the original object now, and they can call set and there on it. So set would let you set the counter to something. But what if you wanted to do something that's conditional on the current value of the counter, right? This is where you would normally get into locks. You might say, hey, get me the counter, and then set the name to Baz plus the counter value. But by the time you set Baz to the counter, the counter could be different. And so you could be getting into a race condition and be writing code. If you had a there function on references that you had, then you could actually pass code to be executed atomically in the context of those variables, which is a pretty cool paradigm. This is just like a really sample API that I wrote, but you could imagine this being really useful in a, let's say, cross-chain context where you might want to do some conditional logic, like buying your plane ticket and hotel room at the same time. So a there call is a way of performing an atomic operation on the other end of a network boundary. So anyways, that's a whole lot. I've actually gone pretty fast, so we'll probably have a bunch of time for questions. And I might just end up kind of reviewing and discussing where I think these can be useful. But here's a review of the stack that I just showed. So the way that that machines are thought of is as logical machines. You can be an individual machine, you may be a quorum of machines, or you may be a public blockchain. But at the kind of Swingset layer, these are all just conceptual machines that are communicating to each other. And so the kind of ergonomic way that we're trying to make it programmable is that you could basically have objects that are still just getting shared across those logical machines. And it doesn't really matter if one feels like a blockchain or if one feels like a quorum. From the developer experience perspective, these should basically be like, either you have a reference to the object and you can use it, or you don't. And that gives us just a really nice abstraction to then talk about the kinds of e-rights that we've been implementing all along. The first such example of this at MetaMask, I think, is the token allowance, which, to be fair, isn't useful for all applications. It's definitely used more than is ideal. But if you think of an allowance as giving somebody a reference to a small portion of your tokens, you can see how we could kind of create this into a more ergonomic way to program around a lot of the notions we have today. So today you get an interface to a contract, and then you have to wonder, oh, am I the owner of this contract? Am I not? Etc. Instead, we could kind of just have your wallet full of all the things you can do, period. And each one of them is a function you can invoke. And that's kind of how this starts to relate to us in MetaMask, is that we're really, at the end of the day, a user consent tool. And we're trying to make it as easy to reason about the kinds of authority that users are managing as possible. And it just so happens that, object-oriented programming evolved out of a conceptual need to organize our thoughts around clusters of things. And so it maps really well to end user experience also. So I kind of see this as a continuum of trying to reason about compute digital authority in the most human-friendly way as possible. By getting the internals correct, I think it's going to be increasingly easy to make the user experience of these increasingly sophisticated authorities more and more manageable. Cool. So that's all the slides I prepared. I know that's a mountain. I probably expected myself to go way over time, but I can just go to questions if anybody has any.
Yes, we do have some questions. The first one we have is from, Horatio, would you like to come on screen to ask the question to Dan? You can just text in the chat if yes. If no, that's fine. I can read that to Dan. I know sometimes we don't have our videos ready, but that's up to you. I'll give you the option. Yes. Okay. Well, we're going to invite him into the stage. Great. Awesome. All right. So I'm sending you an invite right now. Just make sure to accept turning on your camera and audio. Horatio, when you get that.
Yeah.
There we go. Yes. Technology. Welcome.
Hello.
Hi, how are you?
Can you hear me?
Yep.
Yes.
Okay. Well, so it was about their functionality. I think it was. How do you? Or maybe it's too deep for this presentation. But how do you reconcile the state if two different machines have, there was a slow communication or whatever, two different machines have evolved their state in different directions. Suddenly they try to send some reference to each other and they realize that they are in not compatible states. Is there any mechanism for that? Or
I'm trying to figure out the scenario that you're referring to. So just real quick, are you referring to the deadlock description I referred to, or you're talking
Yes.
about? Oh, you are talking about. Okay, so I think the deadlocks actually, at the end of the day, there is a case where you can't get away from them. So and actually, I kind of alluded to it, like the train hotel problem, where let's say you want to buy a train ticket that's on one. It's on one blockchain and you want to get a hotel room atomically from another one. I suspect that the way that this is resolved in blockchains is buying at least a temporary option, like an exclusive option on each of those things while you resolve them. So having a times deadlock probably is inevitable. I think that there's a really cool, I have a fantasy that we can make an API that's like this for end users, but where you could give it a reference to two remote objects that are on different logical machines, and it could help automatically reconcile them, check out the deadlocks into a shared machine. But that is getting to a layer of user convenience that is beyond the actual like practical promises of this programming model. So I think that's the kind of thing that could be provided by an additional, like a protocol. We could say, oh, my plane ticket expresses the optionable protocol, so you would be able to buy a temporary option on it, and then work from there. Yeah, sorry, no magical answer there. I think that you're very right. That is you jumped right to one of the hardest problems that I kind of glazed over. Sorry that I don't have an easier answer to it.
Don't worry, I was in the cross-chain team, so that's why I jumped to some of the. Okay.
Yeah. Oh, yeah. That makes perfect sense. Yeah. So I'm sure we can think of better user experiences for it, but yeah, ultimately, if two assets are on two different things, you either need an exclusive option or you're going to have a race condition.
Okay.
Yes. Thank you, Horatio. The great question, because then that gets us thinking, gets Dan thinking and team about how we can solve some of that stuff. Thank you very much. All right. Okay, yeah, we do have another. And this one comes from Andrew. Again, I'll ask anybody who has a question, if they'd like to come and ask the question on video, like Horatio just did, please just ping me on the Slack and I'll invite you in. Okay, that's okay, Andrew. Okay, so I'll ask his question. How would compartments or writes work with plugins from MetaMask Snaps?
Yeah, cool. So MetaMask Snaps is very much one of these little solo VATs, so it's basically a VAT, and so you can have a quorum one or you could have an individual one. And so and actually what's not represented here is that an individual machine can contain multiple VATs. And so one way of thinking of snaps is that we're actually spinning up VATs on a per snap basis, or actually we might go for a per source of the snap basis. So if you're a publisher of many snaps, we may just put all your snaps in the same VAT. So they might actually have synchronous communication with each other, but we haven't really increased the threat surface because if you're distributing all of those VATs, you kind of you de facto have access to all of those objects. So we run this kind of unique JavaScript runtime, a compartment more or less, and and initially, we're going to be providing our JSON RPC API to those. What the CAPTP discussion gets to is that eventually it gets really interesting if we're able to share these presences in addition to a JSON RPC. And I think that it's a really kind of important developer experience thing to consider. Today, we're really used to like, oh, okay, well, there's the RPC API, right? And then the wallet exposes that. And then every developer, what do when they get the RPC API? They put it into Ethers or Truffle, right? Or Web3 because they don't want to touch it because it's just not ergonomic. It's got some API you're going to call .send or .call, or is it .transfer or whatever. And the API is just so unlike the underlying authority. And we make that normal because we live in a world where we have to write bespoke APIs for everything we want a user to be able to do. But if we were programming in an environment where pieces of authority were constructed as objects that can be exposed as presences to things, then we could provide snaps an additional API that allows them to share objects between each other, objects or presences between each other, which I think it just increases the composability. Well, sorry, it doesn't just increase the composability. It does make for a better developer experience, but there's also an argument that this kind of construction of authority is fundamentally safer. In particular, it solves a problem called the confused deputy problem, which is one where a given machine is interacting with two other agents or more, and therefore is unable to distinguish authority that it has as coming from one or the other. There's a whole Wikipedia article on the confused deputy problem, and there's a link to it on the final slide. But basically, there's some literature, partly one by Tyler Close, that argues that it's impossible to solve this kind of security problem, which includes cross-site scripting and cross-origin request forgery. It's impossible to solve those problems with access control lists, and only an object graph can, or maybe not only an object graph can, but an object graph can, because you preserve the context that each piece of authority comes from. Instead of saying, oh, well, I have this user's token allowance, so I must be able to, you might have an object that represents the allowance you were granted for a variety of purposes. And so suddenly you're not going to get confused about whether or not this is the rent money or this is just for buying a lunch today, because the allowances can preserve the context that they're granted within. Anyway, sorry, going a little deeper in there, that's something I've been thinking a little bit about and working on helping to articulate. So I think it both improves developer experience and actually has some beneficial security properties that are just not addressed in other models.
Awesome. And did you see his comment? He said, what's a VAT?
What's a VAT? Oh, yeah. So these VATs, it comes from the term brain in a vat. Like if you're a brain in a vat, you don't know. This is the idea. So these VATs, they could belong within machines. They could each be their own machines. But what they are internally consistent JavaScript runtimes. So when we talked about a swing set is a type of VAT, but a VAT could be run on many machines. It could be on one. All it knows is it's just a regular runtime. So the Ethereum machine is a VAT. It is internally consistent. It doesn't know if it's actually being emulated within another machine or not. It's just a single machine.
Awesome. Okay, we do have another question from. And he's saying VAT equals synonymous with sandbox. Does that?
Yeah, a VAT is
accurate?
Basically synonymous with a sandbox. That's probably fair to say. Although I guess the distinction is that when you think of a sandbox, you assume that it's confined. A VAT, we're not making any statement about how confined it is. It could be running on the bare metal, or it could be virtualized. A VAT itself doesn't know which it is.
Gotcha. Okay, thank you. And thank you, Ben. I'm sorry, Andrew with the original question, Ben with that follow-up, and then Ben has some more, and he's giving me the mic to speak on his behalf. So he says, does the there functionality there, and you can see the question.
Yeah.
Functionality work with references that exist in multiple contexts. Example, c.set value, that equation right there, where A, B, and C are objects that are owned by different processes.
Yeah, I'm gonna pull up a little example. So I made a module for doing this called Kaputu, and this does not work yet, but yes, I think it would be cool if one day, and I think it could be, you could construct an API that does this, although there's a lot of internal magic that has to be figured out, where you might get a blog post from one blog and an author from another, and then you might just say, hey, I want to do an atomic operation where I say on the blog post, special thanks to that author. And so that would be atomic. So that's basically the question that was asked earlier, like how would you deal with a multi-machine atomic operation? There's some magic happening under the hood in this example code, right? And I'm not prescribing how to do that. I think it'd be really cool if, let's say, the wallet knew how to check out, like if each of these expressed a protocol for getting a lease on exclusive access, then under the hood, we could maybe get that, execute this code, and then release the two references. But yeah, that's not like a thing that exists today.
Dan, is that asking about the link that was on that slide? Is that available? Is that one of the links I can share out? Horatio was asking.
Yeah, I'll add that to the end of the links.
Okay, great. While you're doing that, we do have a couple more from Ben. He says, what do you mean by quote unquote no API? Since you're sharing object references, is the object prototype being used as a sort of IDL? Does that interface object description need to be shared by all execution contexts out of band? Yeah,
so there's no IDL involved in CAPTP. And IDL is an intermediate, something language. Basically, it's an out-of-band agreement on the interface that's being shared. And so what I'm saying about CAPTP is it very much does not have, no additional API. Oh, no, I'm clicking it. When I say no additional API needed, I mean no additional beyond the object's own interface. So the object's own interface, so the object is passed into CAPTP and exposed to another machine as a presence. That other machine can now try to invoke any method on that object they want. And so we at no point created an IDL. We transmitted no interface information out of band. We merely basically created a unique number that represented one of our objects that we extended to that other computer over a authenticated line. Like, let's say if I've got a line to you and I want to give you my update my tweet function, I'm now passing you a number that when you say, hey, call function number 3, I'm like, oh, that's the channel I have with Ben. He's calling function 3. And now I just invoke it. So yeah, no IDL, no additional information. The goal of CAPTP is very much that you feed objects in, and then they're available to the other side. And that's traversing those objects, that's calling methods on them, getting records out of them, passing object references to other objects, including objects provided by other machines, in a way where those other machines are now able to unwrap and resolve direct references to each other, which is what the handoffs refers to.
Yeah, and Dan, do you see what Ben just posted? He said, I guess the crux of the question is, when you pass that reference to another context, process, VAT, whatever, does that context need to know the structure of the object that's being referenced? And he's saying it sounds like yes, but is that correct?
No, the current, so funny thing, I had once implemented something that was very, very similar to CAPTP, and what it would do is it would traverse the object, it would get all the keys on it, and it would pass that to the other interface. So the other interface could do an object.keys and then know at least what functions are available. The current implementations of CAPTP that Agoric are maintaining, they don't even do that. They say, hey, Dan just passed you object 1, and actually that could be an object or a function, and you kind of have to know what it is. Now you can hit it, and actually when you try to invoke a function that's not available, the error returns what is available. So anyways, we can work on the ergonomics of that, but all it is, it's a function reference. So the presence you get on the other side, it looks like an empty object, except when passed to an E function. Sorry, I don't have any sample code for this. It gives you back a proxy that allows you to basically call any function name on it And if that function name exists, you'll get a result from it.
Thank you. Thank you, Ben. One last question for Ben. He's on fire. When you first went to add SES to MetaMask, did it break anything that you didn't expect it would break?
Yeah, lots of stuff. Well, just so when we first added it, you know, like I said, the first step is lockdown. So try locking stuff down. And yeah, you just learn about lots of little things like, something tried to mutate array, yada, yada, yada. I wasn't leading those efforts, so I can't like speak directly to the many things that were hammered through. I almost want to see if we can pull Kumavis in, who's been doing a lot of that work through the LavaMoat project. He's basically running our entire dependency graph through a compartment shim, so that every single one of our modules gets nothing except for the APIs it requires. So even though these modules weren't constructed in this kind of pass by reference way, you know, because modules have their own require statement and they might access their own global APIs like fetch or process or whatever, we're still able to generate a policy file from the parent usage and then reason about that at a kind of layer where you say, oh, does it make sense that a stream module has access to the network and the cookie or whatever?
Great. Thank you. And thank you, Ben. Yeah, I just posted a link to Dan's slides here today. So he does have some great links at the end. I don't know if you're adding that one in that Horatio asked about. But of course, if there's any other questions right now, I know we might end a little early today because you were action-packed there, Dan, with all the info, but it was great. And thank you everybody for asking to dig a little deeper on some of the topics. If you have any other questions that pop up after this workshop, which happens, feel free to reach out to Dan on Slack. Please join us on the ConsenSys Hackathon 2021 Slack channel. That's where we'll post replays of this, as well as the slide deck again, if you missed it here. And also, yeah, you can reach out to Dan and have conversation there. The final thing I would like for you to leave, Dan, if you can, is I know you did another workshop already, but again, to inspire anybody on here who's still thinking about participating in the hackathon, some inspiration and ideas that they can maybe think about in regards to that.
Yeah. Oh, yeah. So I laid this out here because for part of the hackathon, because for me, this set of tools has been really, really eye-opening in terms of like what can be done. Like the idea that, hey, you can add the compartment shim to a JavaScript module and now make it kind of safe to collaboratively code in it. Like I could see benefits to that in, I don't know, truffle teams, or like, you know, I could see, and allowing a there function could be probably really efficient for exposing a blockchain query method where there might be subsequent queries dependent on a previous one. So you can effectively pipeline your query. There's, I think, just a lot of really powerful stuff that can be done when you make your code easier to collaborate with and to extend. And so I'm sure you guys all have really exciting projects that could benefit from a little bit faster innovation, but you don't want to compromise on security. So I hope these tools have been, interesting and hopefully useful to you.
Yeah, absolutely. And yeah, Ben mentioned this sounds like a good or an interesting replacement for ETH_call. So yeah, anything that kind of pops up as you're thinking about all the stuff that Dan talked about. We love the idea of you guys innovating on this and really just opening up the questions and the space around solving some pain points that we know are there. I am going to post right now. We have a design thinking. So if you are interested in hacking on this idea or any of the ideas that we've presented in the workshops, or you just have already that you're ready to kind of bring to life. We have a design thinking workshop tomorrow that's really great for just like the anatomy of the hack and then taking it into the real world, the anatomy of the pitch. So this is an idea that you can actually present to investors and so on. And then, this is not just an internal thing in terms of your ideas, just use this as an incubator, if you will. We also have team building sessions we're setting up for anybody who's interested, so we can help you get your team together to crew up or to help vet your ideas and guide you in a successful hackathon. So please feel free to join us there, and then you can find all that stuff at that green button at the bottom there, that's our Confluence page. So all the stuff about this event, all the workshops, signing up for the hackathon, the prizes, how the submissions are evaluated, all that good stuff is there. So thank you again, Dan, for doing another workshop. Amazing as usual. And again, if anybody's interested in connecting with Dan offline or online, but on Slack, I'm sure, Dan, right, you're open to any kind of questions and conversations. So thank you again for joining us. We hope to see you on the next workshop. And thank you, Dan, again.
Cool. Thanks a lot for hosting, Shay.
All right. Bye, everyone.